Let's do two full examples of simplifying radicals. We not only have to take the square root of a normal number, but we also have that number multiplied with an even exponent, and we also have an odd exponent. I'll do two full examples here. Just as a review, to take the square root of an even exponent, or a variable with an even exponent, we have the shortcut of taking half of that even exponent, and that's our answer. For odd exponents, like x to the 15th power, we want to break down that odd number into its even components and the one that's left over. So if you want to think of it as just subtracting 1 from the exponent and listing that there, that's fine. Because the reason we do that is so that we can then take half of the even exponent. When you take half of the even exponent, you need to make sure that you remove the radical sign from that portion, because we did the math there. However, you can't simplify just normal x. You can't do square root of x and simplify that any further. So we leave that as the square root of x. Okay, let's get started. To do the square root of 54, I want to find two numbers that multiply to get 54, but one of them is the biggest square I can find. That's 9. 9. And it happens to be 9 times 6 to get me 54. So I'll leave those there. I'm going to go slow, so I'm not going to do the square root of 9 to be 3 yet. And in that same spirit, since I'm not going to do any square roots yet, I prefer to just leave my even exponents just as they are, just so I can make sure I don't make any mistakes down the road. I'm going to leave everything in the second step within their radical signs. And one reason why is to keep it consistent with the odd exponents, because I want to break that y to the 9th power down into its even component, 8, and the one y that is left over. So I'll just write the lone odd y out next to it. Okay? At this point, what I'm going to do is I'm going to locate the terms in this expression that I can do the square root of. The square root of 9 is 3. So I did that. So I'll go ahead and cross that out. The square root of x to the 6th is x cubed. I took half of that 6. That's our little shortcut. And what else can I do? I can do the square root of that even exponent, the y to the 8th. And that half is y to the 4th power. Now what? Now I have these two expressions. I have the square root of 6 right here. And I have the square root of y. Neither one of those I can break down any further. So you're kind of just not going to do anything to them. I mean, you're literally just going to rewrite your radical sign and put your 6y back in there. There's nothing you can do. You can't do the square root of 6. You can't do the square root of y. So this is your simplified answer. Okay, great. Let's move on. I'm going to do the exact same process. We have that -8, which can't communicate with anybody yet because we haven't really done anything. So I'm going to just list the -8 on the left-hand side for later. I need two numbers that multiply to get root 72, and I'm going to keep them in the radical signs, remember, from the second step of the last problem. One of them is the biggest square you can possibly find. That's going to be 36 and 2. The square root of 36 times the square root of 2 is the square root of 72. So that's great and dandy. I like to leave my even exponents as they are for just this first step, and then I'll come back to it later. So that's going to be f to the 10 still. And then odd exponents, you want to subtract 1 to get its even component. That'll be z to the second. And then the odd man out, the odd z that's left over. So that's just normal z. Now, let's go through and see what we can take the square root of. I have that negative 8 still there. The square root of 36 is 6. The square root of f to the 10th power is f to the 5th power. The square root of z squared, take half of 2, that's just 1z. So I'll put my z there. And then finally, what do we have left under this radical sign? You have a 2 and a z. That's what's left over. We're not quite done yet. We're basically done, but I threw in that, that negative 8 in front of the whole radical there. So what do we do with that? Well, that negative 8 there, I want to find something for that negative 8 to communicate with, namely this other number here. Negative 8 times 6 is negative 48. Everything else will stay the same. So I'll just copy down everything else here, f to the 5th times z, and then I'll have the square root of 2z still there as well underneath the radicand. And of course my pen is not really working with me, but there you go. That is our final answer. All right, we definitely will be doing many examples just like this.